Hi guys, today we're going to do 2.6 polynomial inequality. So let's do some examples here. Of course, we have solve f of x equals g of x. So what I do is I take my f of x equation and I set it equal to our g of x equation, and then we solve. So 2x equals 6 and x equals 3. So we have our one solution of x equals 3. Now, when we're doing inequalities, though, we have to remember that there's more than one solution if there's any at all. Okay, so let's keep in mind that this is less than. So what I'm going to do is fill f of x and g of x in. So get 2x minus 1 is less than 5. And then I continue to solve. 2x is less than 6. X is less than 3. Now, we can keep this in inequality notation, just like this, or we can do it in our interval notation. The values that are less than 3 are negative infinity to 3. Okay, same thing as if I have greater than. So 2x minus 1 is greater than 5. Solve 2x greater than 6. X is greater than 3. So the values greater than 3 are 3 to infinity. Just keep in mind, if you divide or multiply by a negative number, we have to switch that sign, and we would be saying that differently. So let's look at our next example. We're going to graph f and g on the same axis and interpret the solutions from above, okay? So let me do f of x in purple. So f of x, we start at -1 and our slope is +2. I'm going to get my ruler to make sure it's on point, or you can do a straight edge. Okay. Then I'll grab another color. Let me do green, and we're going to 5. So 1, 2, 3, 4, 5, and it is a horizontal line. Okay, there we are. Now, let's interpret what we saw above. So when they equal, when they are the same, as you can see, they are the same at x equals 3. Okay, right there. Now, when is f of x less than? F of x is less than g of x below. So let me just say f of x is less than g of x below. So, okay, where f of x is greater than g of x above. Okay, that's a nice simple way of putting those together. Now, again, we can look at how this is. The solutions of f of x and g of x are the values where the graphs intersect. It's where they are the same. Okay, and that's where we get the less than is below and f of x above for greater than. Okay, make sure you talk about in the order. F of x is above g of x. So if it was flip-flopped around, make sure you put that in the correct order. All right, so example 2. The graphs of f of x, x plus 2, and g of x, x squared are displayed below. Use these graphs to answer the following and explain what is being represented algebraically by the equation or the inequality. Okay, so when we're solving, luckily our graph is right here, so we can just look. Equals means where they intersect, right? So intersect. So where do these two graphs intersect? They intersect at x equals -1 and x equals 2. Now solve. Where is f of x above? because greater than means above g of x. So f of x above, let's remember, f of x is the linear equation, and g of x is the parabola. So where is it above? Well, it's above g of x right here, because here it would be g of x above f of x above g of x above. So that means that it is above between -1 and 2. Because it's not equal to, we have parentheses, so between. I'm going to switch colors so you can see this. Here we have f of x is below g of x, so below. So here's g of x, and here's where we are under it, below it. So we have two intervals since I have two circles. So -infinity to -1. Now, because it's equal to, that means it's a bracket, and then bracket to infinity. Lots of times, guys, what I'll do is, because we're talking about above or below that second equation, is especially when you're doing with a graph, I would highlight which one you want to be staying still. So we're looking, f of x is below this, f of x is above this, f of x is below this. Okay. All right, solving. What if we don't have a graph to look at? Is there another way you can do this? Yes, we can use a sign diagram or a sign ray. Some of you might have already learned this in secondary 3, but we'll go through it again, okay? So the first thing we're going to do is look at where it equals. We want to find out where it equals. So I'm going to set these two equal to each other and solve. Now it's an x squared, so I know I have to bring everything to one side and then factor out. So I get 2x squared plus x minus 3 equals 0. Now I'm going to factor that out. I'm going to factor quickly, guys, because again, if you need that practice factoring, then use that time wisely. And ask me if you need help. So when I factor, I get 2x plus 3 times x minus 1 equals 0. That means x equals -3/2 and x equals 1. Okay, so this is when our two graphs would intersect. But we need to figure out where it's above or below, okay? So when it comes to sign rays, the first things that you're going to do is put these values on the sign ray. Okay, you want to put it in order. This is -1/2 and this is 1. So -1/2 or 3/2. I want to put 3/2 and 1. Okay, now this is how you do the sign ray. For each of these, it has its own row. So what I always do is add the number. Okay, everything to the left of it is a negative, everything to the right of it is a positive. So if I have my pen at -3/2, to the left is negative, to the right is positive. Now that was just for -3/2. Now I'm going to do the 1. Put my pen at 1. Anything to the left is negative, to the right is positive. So I have negative, negative, positive. Now, I'd just like you to keep in mind, because we might do this in the next couple of examples. These are the multiplicities of 1, so that's why we only have one row for each. Now, I'm going to multiply two straight down. 2 negatives make a positive. 1 negative makes a negative, and 2 positive makes a positive. I forgot to put my light on. All right, now, since we want less than or equal to, well, what type of values are less than? Negatives. That's what we think about. Less than values are our negatives, and our greater than values seems more of our positive. So if you see, where's our less than, our negative values, it's right in the middle. And I also want you to keep in mind that this is equal to, so it's going to be brackets. So our answer is -3/2 to 1. And there is our answer. All right, let's see what else it has us doing. All right, it has us practicing some more here. Okay, so again, what was the first thing I did? I solved. So x squared minus 2x equals 1. I'm going to solve this out. I'm actually going to use a different pen, guys, so we can. Moved. Sorry, guys, hold on. Let me share my screen again. Okay, hopefully that worked. Switch. There we go. Okay, so I set those equal and then I solve. What I notice though is when I have x squared minus 2x minus 1 equals 0, I can't really factor this out. Okay, it would be nice. There we go. So what I need to do is use the quadratic formula to be able to get the values here, okay? So -b plus or minus the square root of b squared minus 4 times a times c all over 2a. All right, I'm going to do this quickly, guys. When you simplify this, we get x equals 1 plus or minus the square root of 2. Okay, so on my sine wave, I'm going to have 1 minus the square root of 2 and 1 plus the square root of 2. Okay, the first value, everything to the left is negative, to the right is positive. So that was for the 1 minus square root of 2. Now I'm going to do the 1 plus square root of 2. Anything to the left is negative, anything to the right is positive. Multiply straight down, we get positive, negative, positive. And as you can see, we were looking for greater than. So greater than is our positive numbers. So we've got 2 intervals we're making and no brackets because it's not equal to. So we get negative infinity to 1 minus square root of 2. And we get 1 plus square root of 2 to infinity. Okay. All right, next question. We've got x squared plus 1 is less than or equal to 2x. I want equals, not, because we're going to solve for that value first. So I get x squared minus 2x plus 1. All right, when we factor this out, it would be nice if this would actually not be blurry for you guys. What you find is you get x minus 1 squared. So x equals 1. Now, remember earlier I said we're going to run into the multiplicities. So when I put this on my number line, I can't put down 1 twice because it's in the same spot. So what happens is when the multiplicity is an even, we put the row in twice. Okay, even because when you do your multiples, whether you're multiplying in 2 or 4 or 6, you're still going to get the negative times the negative is a positive sort of thing. Okay, so let's look at 1. Everything to the left is negative, everything to the right is positive. Now, because it's the multiplicity of 2, I'm going to copy that same row again. Okay, that would be a positive and a positive. Now, keep this in mind. It says less than or equal to. Well, as you can see, there is no less than, but what do you see? There is an equal to. So we have to do the value of 1. The way to represent that is to do your E brackets because it's only one value. Okay? All right, what else do we got here? Oh, one more problem, right? So on D, oh goodness, we have an x to the third, which means to factor, we have to use synthetic. Okay, you have to go through your whole big issue of all the synthetic. I'm going to give you the one that works now just so we can get through this. So actually what works is our -4. And I say -4 because it means x minus 4. Okay, so I have 2, -19, 49, and -20. Bring down the 2, gives me 8, gives me -8, gives me -32. Okay, what did I do wrong? Oh, 19 and 8 is not 8, it is 11. There we go, looks so much better. 44. So that gives me 5, that gives me 20, and that gives me 0. Okay, so right away I have this x minus 4 times 2x squared minus 11x plus 5 equals 0. I need to factor that again. I get x minus 4 times 2x minus 1 times x plus 5. Again, if you need help factoring that, make sure you ask me separately, okay guys? We've been doing it for years, so I'm assuming that you're really good at it. All right, so I get the values of x equals 4, x equals 1/2, and x equals -5. Remember, when we make our sign right, we have to put it in order. That's one of the biggest mistakes people make. So we have -5, 1/2, and 4. Now keep in mind that they are all multiplicity of 1, so I just need one row for each. So for -5, I get a negative, positive, positive, positive. For 1/2, I get negative, negative, positive, positive. And for 4, I get negative, 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 positive. Okay, let me go straight down. 3 negatives make a negative. 2 negatives is a positive, negative, positive. Now let's go back to our sign. As you can see, I keep rewriting the sign because I want to make sure that I'm identifying the correct one. So this is less than, so I want my negative signs, which leaves me the answer, and it's not equal to, okay, it's not equal to, so it's -infinity to -5 and 1/2 to 4. And we are done. Be careful on those examples of multiplicity of 2, because remember you need 2 rows, and when you go straight down. All right, guys, good luck.